Video is on the ranges of values of which your objective remains optimal. So that's what we're doing in this video. So of which objective is optimal. Okay, so in this video, what I'm going to do is that I'm going to just show you a technique that you will just grasp, and once you grasp that technique, then you can handle any question on the ranges of values of which the objective function is optimal. So I'll give you a possible linear programming question. So suppose you are given this question, z is equal to what? 25x1 plus 20x2. Okay, then they give you subject to just other constraints in the question, 20x1 okay plus 12x2 less than but equal to 2000. Next, 5x1 plus 5x2 less than but equal to maybe 540. So you might be given that linear programming model, then you're asked after, like, you solve it using simplex method. You might be asked, okay, solve this question using the simplex method, and then I'll just go to the final solution as of this video, because our focus is to get how do you start to tell those ranges of values that that keep your objective function optimal. So I'll just show you like the last matrix after you have solved your simplex method. So you would have done your simplex, like the last one, and you've been like reached at this stage. Let me just write that x1, x2, s1, s2, and your right hand side, of course, there. And okay, you have your z there and your basis here. So you're trying to, okay, you're on your last matrix at this point, and you get this solution of some sort. And then we have these figures in the slack variables, 1/8, -1, -1/8, and then -3/10, 9.5 equal to what? 88 and 20. So suppose that's actually the solution for that linear programming model that I showed on the screen. I just rushed to the final answer to explain this part, that this video is focusing on the objective function, the ranges that keep the objective function optimal. So your focus is on these slack variables as well, just like when you're looking at the objective function, I mean the ranges that keep the right hand side as well objective. The slack variables are your main focus. Remember this. So what you're going to do is that we follow this to want to understand what we're going to do from here, because these slack variables will work together with the objective function given in the question. That's why we're using the objective, because this is about the ranges that keep the objective function optimal. So let me take you back to the objective function, the one we started with. Z is equal to 25x1 plus 20x2. So what we just picture, this is the model that the objective follows. Okay, so this is what we put here, C1 x1 plus C2 x2. So those letters you're seeing there, first of all, they are representing first the model that the objective function follows. The C just stands for coefficient of coefficient 1 for x1, then the C2 is just the second coefficient, and the x2. But here just try to get the concept. If anything, this is the model that the objective function follows. And as you start computing those ranges of values, you'll be like, okay, you will take C1, right? C1. Okay, you take C1 and start first of all by finding the ranges for the first part of the objective function, which is the C1. I'll explain as we move and to be making sense. So if you picture that matrix, you rewind in the video, what happens is that when we check that simplex tableau, in the basis column you had seen x1 and x2, right? So what's going to happen is that where there was x1 in that basis, we will substitute by c1. It's like c1 moves with x1. I hope this will make sense. So it's like you are on that last optimal solution of your simplex table, and now you're trying to find those ranges which your objective is to optimal. So you follow this model first, and then where you find x1 in your final matrix, you will be substituting that by c1. I hope this will make sense, because these are together according to the model you're seeing above. And so you know that, okay, your c1 will come and replace this x1. That's what we meant. Then when we go below, x2, it's there. You look at the coefficient in the objective function, right? Which coefficient was with x2? Because remember, just focusing on the objective function, it was 20. And just that's all. That's the technique that we follow. So x1, so it's like, first of all, you start by first solving them one by one. You say, okay, for c1, what would be the ranges? Then even for c2, I'll come and show you what we would do. But first of all, this is what you do to first solve for c1. So once you do that for c1, then go to your slack variable 1 column. You will find there was 1 over 8 and there was negative 1 over 8. What next from here? You will start multiplying these numbers here, like c1 will be multiplied by that, 20 will be multiplied by that. Okay, that's what you do. So this times that, then plus 20 times 1 over 8. That's what we're doing basically. So c1 times 1 over 8 gives you what? Then this is supposed to be c1 over 8. The next one, what is 20 divided by 8? I should believe that's 2.5, if I'm not mistaken. 20 divided by 8, yes, 2.5. Okay, and negative, by the way, because this was negative 1 over 8. Then how do you now represent this? What next from here? Well, you found this, right? Just do this. You're trying to get those ranges. So you will say, okay, you got c1 over 8, and then you had your minus 2.5, and we will just say that they are greater than but equal to 0. Take note of this. After you've done those figures, you found them, then take the 2.5 to the other side. So see, because you're just trying to make c1 the subject of your formula basically here. So that gives you positive 2.5. Multiply both sides by what to kill this 8 on c1? By 8. Just multiply both sides by 8, then you're done. So this one will be therefore equal to c1 will be greater than but equal to what? If you do that, you will get, what is 8 times 2.5? You will get 20. Okay, remember we have just dealt with what? Slack variable 1. We're not done, right? When you're getting ranges, don't we follow this model? This is the model we follow when you're getting ranges, huh? So it will be like c1 will be in the middle, and you put a number here, you put a number there. That's how you get ranges. You put a number on the left side and then on the right side. That's what they mean by the ranges. So it's like the answers you find after using S1, they come this side to your left. Okay, so that's why we put your 20. What about on the right side? What do we put? Go to slack variable number 2 and check which figures were there first. There was a 3 over 10 and we had half. Okay, so we're still under the same model where we had, okay, we said c1 will be there and then we will use 20. Mind you, we're just following that part where we said, okay, c1 will be replaced by x1 and then x2, that's 20. If you rewind in the video, you see why we did this. Then now at this point, you're now in slack variable 2 column. You're in S2 column, you're trying to multiply with this C1 and the 20 at some point. So C1 with the 3 over 10, 20 with the half. What is C1 times 3 over 10? Isn't this just going to be negative? Okay, let's just say negative 3 multiplied by C1. Let me just write that well. 3 over 10 C1. The next one, what is 20 times half? That's 10, right? Okay, here at this stage, what next? Because remember, we're trying to just find what will come and substitute on this side, this right hand side of that range there. That's what we're just trying to do. So we have our 10 and negative 3 over 10 C1. So we have here, or at this stage, okay, this one is just positive 10, right? And then as well, we just do this, that they are greater than but equal to 0. Then try to make C1 the subject of your formula again. So okay, first of all, you can do this. 3 over 10. Sorry for that one. Let me try to rewrite this. And then you cross it as well. And then get rid of the 10 there. You just multiply both sides by 1 over 10. Since it's like an equation. If anything, the inverse actually multiply by 10. Actually, that would be the answer you get. Multiply both sides by 10. Actually, then you will get your final outcome, which is 100. And you have what? 3C1. You still have that part over 3 over 3. So therefore, C1 is equal to what? 100 over 3. As your other range that you will put where? On the other right side. So it's now that you have, it's now like this. You have your C1 model there. We found the first 20, and now we have 100 over 3. That's all. That's how we find the ranges of values on which objective function is still objective. So it depends on how many variables in your objective function. If you just have x1 and x2 in your objective function, you will just need to deal with C1 and C2. If you have x3, you will have to include C3. But in this case, we only had 2, x1 and x2 in our objective function, and that's why, first of all, you deal with C1 just like this. Just follow this procedure, you'll never go wrong. And then for C2, this is what I'm about to start explaining now for C2. It's very similar as well. So we're still on that model. Like we said, we go back to your simplex table, and you have this in the basis column, right? Your x1 and x2 variables are there in the basis of your final simplex table. Now you're solving for C2. If you follow that model again, this is what we said in our model. So C2, it moves with what? X2. So now you're looking for C2 at this point. So C2 will substitute there what is X2. What about an X1? What do you take? This time around, we take that coefficient that was on X1 in the objective function, which was 25. Okay, we're moving. Same story. Go to the slack variables in the simplex table, the final simplex table. We had 1 over 8 and negative 1 over 8. Well, we're in S1 right now, by the way, first. So solve them one by one. Let's start with S1 to get the first range for C2. So it will be like 25 by 1 over 8, C2 by 1 over 8. So 25 by 1 over 8 is as good as 25 over 8. Okay, I just avoiding the decimal, so I'm leaving it as a fraction. This one as well will be C2, negative C2 over what? 8. Okay, we have these answers, right? Let's just erase the screen quickly. So you have negative C2 over 8, and then you have your plus 25 over 8. And just always do this. Always when you pick the first treatment, always say greater than but equal to 0. Then make C2 the subject. C2 will be made the subject first by leaving it alone, this side. Negative 25 over 8. It's also becomes negative when it crosses that sign. And then what next from here? Get rid of that 8 in the denominator of C2. Just multiply both sides by 8. That will be there. It will cancel. Even this side multiply by 8, it will also cancel. You will remain with negative C2 minus 25, like this. Then what next? Just multiply both sides by -1. Then you have gotten rid of that negative sign. So you now have your C2 greater than but equal to what? 25. Your first side range. So it will be like in that same model. Again, you're trying to get the ranges now for C2. Okay. You have the first number you have, which is 25. Let's get the one which will be on the right hand side there over the C2 part. Same model. X1 from that simplex tableau. C2, we're working in C2. The same say we said we'll substitute the coefficient of x1 in the objective. At this point, we're looking at what? S2 now. S2 had which figures? -3/10 and positive half. You're now trying to solve this. So what you're going to do is, again, multiply this by that, that by that. This gives you, what is 25 by 3/10? This is -75/10. This other one is C2/2. Yeah, this stage. Okay, get the values again. So -75/10. So it's first of, let's say C2/2 minus 75/10 greater than but equal to 0. Then take the one to make C2 the subject again in this scenario. 75/10 is the side. Get rid of the 2 below there. Multiply both sides by 2. Get there, you have your C2 left here, less than but what? Greater than but equal to what? That cancels, 5 into 75 is what? 15. And you have your other range. So then you say, therefore, C2 we had 25 initially, of course, and we now got 15. So you can just try to rearrange. When you're writing ranges, you start with a smaller one. So you can just rearrange this and say, okay, 15, that, and that. So basically, that's how you get the ranges on which the objective function is still optimal. So just always remember, if you have x1 and x2 in your objective function, you'll just deal with c1 and c2. If you have even x3, you will have to include c3. But in this scenario, please, when you have x1 and x2, this is what we follow to make those ranges objective, and that's all you need to know.